Hello, everyone, and welcome to Clay Loves Logic, where on this channel I solve logic-based Sudoku puzzles I find interesting. Today, I'm going to be looking at the puzzle On the Run by Sandra and Nala. As always, I'll put the link to this puzzle in the description of the video so you can try it out if you'd like. But with that being said, let's look at the rules. Julius, one of our other pets, escaped. This has happened before, and Nala is usually the one to find him somewhere in our backyard. Today, it's foggy, and she might appreciate some help with the search. Normal Sudoku rules apply. Place the digits 1 to 9 in every 3x3 box, in every row, and in every column. All lines are region sum lines. Digits along a region sum line sum to the same digit n for each box the line passes through. If a line enters the same box twice, each segment is summed independently. Each line has its own color, and elements of the same color are connected. So what that means is this here, this combination of digits will sum to the same, and it looks like it just goes through here. These, whatever this path does, will be separate. This will sum to the same thing that this sums to, the same thing that this sums to. That looks like what it does. Anyways, there's also quad clues. So every digit that appears in a circle, quad clue, must also appear in at least one of its 4 surrounding cells. And additionally, the grid is covered in fog, partially. Placing correct digits will clear the fog from surrounding cells, possibly revealing more clues. Okay, so we have a 2-cell or a 3-line or 3-digit region sum line. And that means we could never have a 5 or a 7 on it. Because if we have a 5 or a 7, we could never add, well, we could have a 5. We could have a 5 if we added precisely the digits 1 and 2 to make 8, or 1 and 3 to make 9. Obviously, we have the digits 1, 3, and 5 in this box. Only one of them can be on the region sum line, which means we need 2 other small digits in these spots. So these digits are going to be from 2 and 4, such that this would then equal 6, 7, or 9. And if it is 7, that means this and this is 7. And if both of these are 7, how do you fulfill this clue? So in fact, these are both 9. And this is going to be a 3, and we'll have a 2-4 pair. Somewhere along here, we'll have 3 and 7. And now we have another region sum line that has to be at least 3 digits. This will equal the same as this. So now we can ask ourselves, what could these even be? They can be 6 or 8. And my next question is, how could this ever be 6? Because to make 6 in 3 digits, you need 1, 2, and 3. And of course, we can see that we can't even put 3. Well, for starters, we can't put 3 there. 3 is in one of these 2 spots, which means it's never on this, which means this is, in fact, an 8. And the composition of digits that gets us to that will be either 1, 3, 4 or 1, 2, 5. Well, sorry, and it can't be 3 because the 3 is over here. So it's only 1, 2, and 5. And then this, I think it could still be 1, 3, 4 or 1, 2, 5. And of course, this is not a 3, but that's all we know so far. 1, 3, 4 or 1, 2, 5. If it's 1, 3, 4, then we need a 3 and a 4 down here, which is fine. If it's 1, 2, 5, more options. Okay, what about 9? Or what about 8? 8 somewhere over here. I'm gonna corner mark that there's always a 3, 7 here, so I don't forget. Oh, and this is a 6 by Sudoku. So there's also going to be a 6 somewhere over here. 3, 6, 7, 8. So this is a 4, isn't it? Yeah, this is just a 4. So this is a 2, and this is a 4. And now this can't be a 2, and this can't be a 4. If neither of these can be a 4, now our only option to do this is if this is 1, 4, 3, or, sorry, 4, 1, 3, or 1, 2, 5. Yeah, so we can't reduce that anymore. But, well, actually we can now, because look, doesn't this just have to sum to 1, 3? And of course it does, because it's a 4 with 2 digits. So 1 and 3 come out of there. And now, can we ever have, so we could never have 1, 3, 4 anymore, could we? Because this cell would have to be both the 3 and the 1. So if 1, 3, 4 are no longer options, then this is a 1, this is a 5, and this is a 2. And that is correct. This is now not a 5. So the 5 is always up here. Great. And then this is going to be 1, 3 as well, isn't it? Yes, it is, because again, it sums to 4 and it needs to do it in 2 digits. Well, I guess that could still be a 3. So 3, 6, 7, 8. Yeah. I'm gonna say that looks like a 6, but I don't know yet. Well, now I know. Well, yeah, first of all, this isn't a 3. Don't I know now? Well, yeah, this is a 1. There's a 3 right there. Yeah, that was silly. 5 somewhere over here. What digits do we even need left? Well, this is not a 1 anymore. This is only 2 or 5. And this is not a 1 anymore. This is only 5 or 7. So 1, 2, 5. Oh, and neither of these are 2. There's a 2 there. It's been available for ages, I'm sure. So 1, 5 pair and 7, 9. And I want to say that whatever this is going to make its way somewhere over and end up here. But I don't know that yet. Always a 6 somewhere in here. Sure. Well, what's interesting, if you think about it, is I don't know the composition of what's happening here, but I can tell you that this is a 4, isn't it? Because 1 and 3 are spoken for, 2 is spoken for, 5 is spoken for, and the 6 in this box is somewhere over here. So this has to be a 4. And if it's not a 4, what is it? It's just 7. But we can see, I mean, oh yeah, because actually the clue is each line has its own color. So this is the same line. So this could never be something as high as a 7 because there's just not enough real estate for it to be a 9. So this is a 4. Now this could still be a 7. I don't know. Well, actually I do know, don't I? Because if it's a 7, it's just 1 and 2. And there's a 1 here. So this is 9, which is going to give us a 9. And it's going to remove this ability to be 6. And this combination of digits we need now just has to be 2 and 3, doesn't it? And it has to be in this order. Now what do we need? We need 6, 7, and 8, don't we? So 7, 8, 8, 7, 8. Two in this box, somewhere there. 4, somewhere here. Six is less known. And so it's 8. But this sees a lot of stuff. What does it see? It sees 1, 2, 3, 4. So it's 5, 6, 7, 8. Yeah, that's not that interesting. 5, 6, 7. In fact, both of these are just 5, 6, 7, and 8. Well, there's a 1 of 2 spots. Okay, maybe maybe we should turn our attention to these. Because these have to sum to this, don't they? And the smallest digits we could even put in here would be a 3 and a 4. And a 3 and 4 would only be in this setup. That would make this a 7. Because we can't have a 1 and a 2 in here, or a 5. So in fact, there basically always has to be a 3 on this line, because the next two biggest digits would be 3 and 6, which would make 9. But if you didn't have a 3, you'd have to have 4 and 6, which would make 10. So it is 3 and 4. And I know it's 3 and 4 because it can't be 3, 5 to make 8. And if it's 3, 6, in theory that works here, but that puts a 9 here, which we can't have. This is a 7, this is a 3, and this is a 4. Okay, we need another combination of cells that will let us arrive at 7, and it's not 1, 6. And I know that because no matter what, there's a 1 somewhere here, and there's a 1 somewhere here. All our capacity for 1s are full. So the 1 is always going to be down here, and it's going to be in 1 of 2 positions. So this is not 1, 6. Now it could be 2, 5. That's valid. And it could be 3, 4. That is also valid. In fact, 2 now goes here as well. Because it's not here, and it's not here. So 2 is only here. So what is this? What is this? It's less easy to tell what this sum will be, because it's never just one. As far as I can tell, it's not. There's not something where it's like just one digit that we can then deduce. There's a multitude. So I guess what are the 3 digits? Excuse me. What are the 3 digits we need over here? We have 1, 2, 3, 4. So we need 5, we need 6, and we need 7. Okay. That's interesting. Maybe. Maybe it isn't interesting. Well, where does 7 go now? 7 can only go in 1 of 2 places. And 1 never goes in the bottom now, so there's always a 1 up here. There's always a 2 up here. Oh, and there's always a 3 up here. Yeah. Oh, sorry, there's not always a 1. 1 could be in this box. But it is true to say that there's always a 2, and there's always 3. In fact, actually, that gives us a digit. Look, there's always a 2 in this row, and a 3, and a 4. There's always a 2, 3, 4 in this row. So this is a 2, 3, 4 triple, which means, well, that actually doesn't give us a digit yet. Well, doesn't it? Yeah, it does, because it forces 1 to be in 1 of these 3 cells, which means this is a 7, and it forces the 1 up here. And then actually we're going to get a 5 and a 1. And that is going to, in turn, give us a 7 over here. That will, in fact, well, this is no longer 7. So this is a 3, 6, 8 triple. And then this is a 2, 4, 5 triple. And this is not 2, but I think, oh, and it's not 5 either, because 5 has to be in 1 of these spots. So this is a 2, and this is a 4, 5 pair. This is never 5 anymore. So 1, 2, 3, 4, 5. So 6 and 8 are the combination of digits we now need. That's a 6-8 pair. Okay. Where does 9 go in this box? Well, this is a genuine 2, 3, 4 triple. And this is a 5, 6, 7 triple. So in fact, this is 1, 8, 9. And that just gives us a digit by way of 6. And then up here, what do we need? 1, 2, 3, 4, so 7, 8, 9. That's not a 7. We have a 4 somewhere in the middle. Five could be anywhere. 6 and 8. And 6 is not here. Oh, okay. Wait, so this is a 2, 6. Yeah, that's 2, 6. So now this sums to 8. But this is never an 8 or a 9. This is always a 1. Because I don't know whether or not, I don't know how far this extends, but if this sums to 8, this can't be an 8 or a 9. That's a 1. And that's a 1. Oh, shit. I pencil marked wrong. I see what I did. Sorry. Okay. Well, it ends here, so this is 2 digits. So I know that at least. I'll proceed with the knowledge that I do know. So this has to sum to 8. So it's 5 and 3. And that means all our capacities for 5 is taken. So this has to be a 5. This is a 4, 8 pair now, which means this is not an 8. This is a 7, 9. So this is a 7. And this is a 9. And this is an 8. And this is a 7. And that's a 6, 8 pair. These digits, 5 and 9, 1, 5, 9. That's not a 9. Yeah, that's not a 1. Okay, great. Well, we know this sums to 8. So it needs to get, yeah, it needs to sum to 8. So what do we need down here? 1, 2, 3. I've made an error. This is not a 3, 5 pair. Oh my goodness, this is on the 7 line. This is a 4. Yeah, which is, no, this is 5 and 2. Wow. Okay, I hope that didn't mess anything up too much. And it might have. Here I was thinking, oh, this has to sum to 8 because this one does. They're different lines. This has to sum to 7. Whoops. So we need 1, 3, 6, and 8 down here. And I hope I didn't mess that up. This can't be 8. If this is 1, it would require this to be 7. Well, no, this could be, if this is 1, this could be 2 more digits, and it could slowly work its way up to 8. 1, 2, 5, for example. Or 1, 3, 4, because obviously 2, 5 is spoken for. Could be 1, 3, 4. If it's a 3, it could be 1, 4. It can't be 1. There's always a 1 down here, in fact. So I'm going to say this can't be 3 now. And if it's 6, it's only 6 if this is 2. And it can't be 2 because that is so this is a 1. Oh, dang, I didn't even think that the line, I mean, the box logic is the same. I didn't know which way the line went, but the box logic is the same. And that's going to say that this is now the 3, isn't it? And this is the 4. Yeah. There's a 6 somewhere up here. So that's never a 6. And that removes that ability to be a 4, this ability to be a 3. Neither of these are 1 since we placed the 1. That's been available knowledge for a while, but that's okay. This is just 8 now. This is 6. It's a 3-8 pair. And this 4 does a bunch. 8, 4, 3, 8, 1, 3, 5, 1, 2, 5, 6, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 6, 7. That 9 is going to give us an 8 and a 9. Oh wow, this is huge. This is 17 and 3. And 2 of them are down here. What do we need down here? 3, 4, 6, 8. And this is not a 3. This is not a 4. Oh, and this is not a 3. This is a 3, just by dint of, well, no, don't get ahead of myself. This could also be a 3. That's sum to 17. Boy, that's a big number. So if we maximize these, call this 8 and 4, this, or 8 and 6 would be the max. It couldn't be 8 and 6 though, could it? Because there's already a 6-8 pair here. And if there's a 6-8 pair here, how could this ever be a 6-8? So this could be one of them, but it's not both. So it's either 4-6 to make 10, and then this is a 7, or it's 4-8 to make 12, and this is a 5. But those are its options. So we have a 5-6-7 triple. So what do we need here? 2, 3, 9. So this is a 3 actually. Hey, we found him. We found the turtle. This is a 2. This is a 4 and this is a 3. And then we must be, yeah, this is a 9. So that's a 5. So that's a 1 and that is a 9. Oh, there's a 6-8 pair. So that's a 4. 5, 4. 6-8 pair. So 7. 7 and 4 is 11 plus 6. 8, 6, 8, 6, 8. 1, 6, 5, 6, 7. 2, 5. 24 minutes, 22 seconds. 1,633 people have solved that puzzle in 385.4 days. I did like that puzzle. That was a very fun puzzle. Yay. The solution is correct. It's good to have Julius back, but how did that little ninja turtle escape? Oh, I like that puzzle. Sandra and Nella, great puzzle. I hope everyone enjoyed watching. Catch you on the next one.